So in this question, we're asked how many moles of water are formed when 2.33 moles of propane are burned. So pause the video and see what you come up with. So anytime you're doing a chemical calculation, you always want to be clear, what are you converting from and what are you converting to? So I always take the time to write down what I call the given, what I'm converting from, 2.33 moles of propane, and then clearly identify what I'm converting to. And we're asked to solve for moles of water. So looking at where I'm starting and where I'm ending up, I know this is a stoichiometry problem because I'm given an amount of one chemical, 2.33 moles of propane, and I'm asked to figure an amount of a different chemical, moles of water. So we take what we're given, what we're converting from, the 2.33 moles of propane, and we multiply by the conversion factor, which is always going to be a mole ratio from the balanced chemical equation when it comes to stoichiometry problems. So the conversion factor has the moles of the chemical that I'm converting from in the denominator. So according to my balanced chemical equation, 1 mole of propane. So I have 1 mole of propane in my denominator, and then in my numerator, I have the moles of chemical that I'm getting to, or trying to find out about, moles of water. And according to the balanced chemical equation, that's a coefficient of 4. So this mole ratio, 4 moles of water to 1 mole of propane, comes from the balanced chemical equation and is determined by the chemical that I'm solving for, which is in the numerator, and the chemical that I'm converting from, which is in the denominator. So my moles of propane cancel out. I'm left with moles of water, which is what my unit is, and that's what I'm solving for. And then I multiply 2.33 by 4, divide by 1, which doesn't change its value, and we end up with 9.32 moles of water. So that's what you got. Give yourself a pat on the back. There are extra practice worksheets in Canvas if you need a little bit more practice.